It's now taped for all posterity.
Okay, construction of the seed.
I didn't get credit. I wanted to.
Rush seems to be winding down. Traffic is moving close to speed. Nothing to report here. Back to you.
During the next 7 minutes, you will see an overview of 6 days' work as a group of students study the motion of maple seeds and design experiments to explain their spinning flight patterns. One wants one's students to learn physics, to think, to do problem solving, effective group work, to communicate effectively, and above all, to accept responsibility for what they do in the classroom. One must provide ample opportunity for the students to practice these characteristics in the classroom and then evaluate their success using performance assessment.
We said gravity was pulling down. The air was going up and pushing us up. Okay? But it had to stop and it had to go around the wing like that. And then up. Okay, this pushes it up. This pushes it to the side, the wind going underneath and over, causing it to twirl. So there's a force on the wing, causing it to move around, and there's a force pushing it up.
So what variables do you think?
Okay.
Affecting?
Obviously, it's how heavy the air is. You know, like real the air pressure.
Air resistance.
Air pressure.
So what you're saying is on a hotter day, it would go faster, and on a colder day, it goes slower?
Okay, if it's a hotter day,
the air be thinner.
that's a low pressure.
Right.
Right?
Concavity. Definitely.
What did I say?
Because I had them straight, and you saw it wasn't doing it when I twirled them. So that definitely has something to do.
It's also directing the air. Directing the air.
Yeah.
We gotta make experiments for this stuff.
The reason why I'm doing this is to make it more accurate. You see what I'm saying?
Developing a simplified model to help understand more complex phenomenon is an important scientific technique, but it is not always easy.
Oh, there's just one more problem with this model.
What?
It's not gonna work. I don't believe it's going to even get us close to what we want.
Let's try it.
Try it. Okay.
It's not spinning. Okay, so why isn't it spinning?
Yes, Eric. It will spin now.
But the bell ending the class fails to break their concentration. During the performance of these tasks, the students usually work together with their groups, but they also have ample opportunity to work individually to develop unique ideas which they later present to their peers for their consideration.
Yes. Did you see that one?
Yeah.
You took off more weight from the bottom?
Yeah.
So we know that's what makes it go down. It's the weight at the tip. The more weight at the tip. It works! Look at it. It works! It works!
Eric, look this one out too.
So we got a big one and a little one. Like I was saying, you could tell there's a definite difference from this 4.5 centimeters wing length to the 8 centimeter wing length. The shorter the wing length, the faster it goes down. The longer the wing length, the slower it goes down. And what I theorize is that it's kind of like a test to show that air resistance does make a big part in it. Because with this smaller wing, you could see it's a lot less air resistance. Therefore, it goes faster.
I don't see any parallelism.
There's a lot of parallelism. The way they're
The
shown.
only rotation is parallelism,
The way they're
right?
no. The way they're
Working one's way through frustration is part of solving real problems.
Yeah,
longer
but this
it takes
thing
to
got
come
two
down.
things to hold it. This thing got only one thing to hold it.
Yeah, we could scrap it. It's up to you.
I don't know. I'm just saying think about it.
It took me 2 hours to make them, but I'm willing to
It's-
scrap it.
it's
If
not-
you think this has nothing to do with the wing here, we can scrap it.
When one finally begins taking data, the work becomes almost prosaic.
2, 1, stop.
3 paper clips. 4 paper clips.
We weighed them and timed how long it took for it to go a certain distance, and we plotted that graph. The graphs that we got weren't very good results, so that's what led us to our second experiment. What all of us basically concluded was that you have a difference in wing area and a difference in mass. Mass is one variable, wing area is another. So we had to strip the two away from each other in order to test them separately. From that model, we got more accurate results. So through the surface area experiment, we found out that the less surface area.
In closing, we wish to share a very small piece of an interview that occurred on January the 29th between my students and a reporter from a state newspaper. You'll hear the reporter ask a student to compare how much he remembers using performance assessment versus more traditional methods.
How does what you're doing in here compare with what you have done in other classes?
I took history last year. I don't even know what it was. And I made 98 straight average. And I don't even remember who was who.
A year from now, will you remember anything from here?
Oh yeah, because when you go in your thinking, deep thinking and everything, you always remember your words. And it's like remembering your family. You remember family members.
Right.
Right.